Hello viewers, welcome back to another episode. In this video we're going to have a look at this Panax Ratemeter. I picked this up the other day and it is a radiation meter. It's designed to take Geiger Muller tubes and yeah, it looked an interesting thing. I wasn't quite sure how old it is, but I'm pretty sure it doesn't work because it rattles and clunks. I have actually had a quick sneaking look inside, and there is definitely some repairs needed. So we're going to take it apart, have a look at it. So as this is a rate meter designed for Geiger tubes, it's going to be measuring radiation. We've got a nice big panel meter there. Unfortunately, there is some issues with this, as in the glass has departed company from the bezel, and it's now actually making contact with the needle and the end stops as well, so that isn't very good at all. We'll have to take that apart and see whether it's actually affected the movement. We've got various controls on this. So we have the range, so we've got scaling factor. So this goes on 10 range, 30, 10 to the 2, 3.1 to the 2, and then 10 to the 3. We've also got an integration selection here, so we can integrate over 1, 5 and 25 seconds. Then just above that we've got a voltage control for the actual Geiger tube, and that sounds very much like a wire round resistor on the back of that. So that runs from 350 volts up to 750, so that's just getting into the area where photo multipliers might be used. So yeah, could be useful. We've got a speaker for your typical Geiger-y clicky thing, and then we've got the connection to the Geiger Muller tube. Not quite sure what that connector is. Might be worth swapping that for a good old standard BNC. Around on the back we have a big clunking mains on-off switch. We've got the mains power input, a couple of screws, and aux socket, so I'm not sure what that's for. External meter, presumably that's for verifying the voltage that's going to be on the Geiger tube. And then we have a couple of adjustment pots for the meter 0 and the range. Right, so let's take this apart. I'll grab my screwdriver. It's all slotted screws, so it's obviously showing its age. Let me pop this out the front. It's yeah, it's a shame you don't have smell-o-vision, because that smells old. Awesome. Right, so we got a large PCB, double-sided, with Panax written on it. Panax RM408. You can obviously spot something that needs sorting out is this capacitor here. That's obviously come adrift from somewhere. We've got a mains transformer over at the back with, I don't know, is that date code? 6938? It's possible. We've got a capacitor just there with June 72 written on it. Where is that supposed to go? I don't think it's... see, yeah, it's broken off from just in there, so what we need to do is certainly reattach that. We won't turn it on until we've done that. So does this capacitor have a date? 1971. That transformer there could well be 1969. Okay, so we got the mains coming into the main switch, goes straight into the transformer. Transformer comes out into, a few taps coming off there. Right, well, I think what we need to look at first is this meter, because as I'm handling this, is with this glass, it's going to be causing more and more damage. So I think what I'm going to do is take the meter out. We'll see if we can take the front panel off and see if we can reattach that glass and see whether it's done any damage to the actual meter. Okay, so I'm just going to remove the front of the bezel off the meter. The screws have actually had some kind of epoxy put on them to stop them coming out, so some of these might be tricky to remove. There we go. So let's see how the glass actually attaches to the front of the meter. So it looks like it was just glued. And the glue has just completely dried up. Okay, the meter actually looks like it might be okay. If you can see it just blowing on it. Moves pretty freely. And the little end stops probably just need to be bent with a pair of tweezers back to where they should be. Right, what I'm going to do, now the meter is actually moving freely, I'm going to put the bezel back on without the glass and just be really careful with this. Connect it back into the rate meter and we'll power that on and see whether it starts to work. I'm starting to see why this capacitor would eventually broken out, because it's not actually, the spacing on the PCB is not quite right for the capacitor. But let's tip this up and remove the little bit of wire that is actually in the hole. Right, I think we're ready to do this. I've just done some basic checks just to make sure there wasn't anything stupid like the transformer was shorted or anything like that. There's no continuity to the chassis ground and all that sort of stuff, so looks like we're good to go. I've set all the controls to the highest count, the longest integration time, the lowest voltage, speakers off, the mains power switch is on, and I also have my high voltage probe. This is a bit kind of a bit excessive for doing this, but this is high impedance, so it means I can measure the voltage accurately. Really what I want to do is give those capacitors a bit of an easy time to start off with, and we'll see how we go. And another thing I can do, of course, is measure the current that's being consumed from my variac. So that'll give me an indication on if anything's going really horribly wrong, because this shouldn't draw hardly any current at all. So what I'm going to do now is turn this on and bring the voltage back up. And we're drawing 1 milliamp. 2, 3, just under 100 volts. Stable at 3 milliamps. Let's see if we do actually have anything here. No, not really. Right, so we're now at 240 volts input and it's consuming 24 milliamps, which seems perfectly normal to me. Let's just measure the output voltage again. So this should be 338, which is pretty much what we saw before. Voltage is a little bit low on the app. That should be about 750, but it's ballpark. Right, well, this thing seems to be behaving itself. At 240 volts, it was only drawing 24 milliamps. What's that, about 5 watts or something? So what I'm going to do is pop this back into its box, and we'll see if we can connect up a Geiger tube to it and actually see whether it will produce an output. Right, one thing I have just noticed is that this does actually have a test 50CS selection on here on the integration. So I think that might inject a 50 counts per second pulse into it just to see whether it's working correctly. So what I'm going to do is power it on. We will try that. So okay, that's gone off scale, but the range is set to 10 counts per second. 30, 10 to the 2. So I guess that would be right. Right, so I've got this set up in full-on bodged mode. I've got a little M408 Geiger tube here set up, and a couple of wires just poking into the output there. It's a bit, it's a bit how you're doing, but it should be fine just to get us up and running. Fine, that's still on the 50 counts per second test. So if we set this to, being careful where I put my hand, 1 second integration. There's not going to be many counts coming off this tube because it's only small. So I'll set this down, and it does look like we're getting some activity. The voltage is probably a little bit low. I'm going to pop this up a little bit. So that should be round about getting close to 400 volts. Let's try the speaker. So let's see what happens if we bring something radioactive near it. Check that out. So the integration time, if we turn that up to 5 seconds, well, I'm quite happy with that. It seems to be working just fine. What I'm going to do now is take it apart again, and we'll take off that meter, take the bezel back off and reattach the glass. And I probably will also make some tiny little tweaks to the end stops which have been bent very slightly, and that can go back in, and I will probably change that connector on the front panel there for a BNC. Right, well, let's see if we can tidy up this piece of glass. Got all this crusty old glue off it, which has gone very, very hard. I'm just going to try a blade first to see if we can. I mean, that comes off pretty easy. And now I'm just going around just doing the same to the bezel to get all this glue off. Right, so I've got the glass and the bezel all cleaned up, so that can just drop into there. So we just need some way to secure that in place. So I think what I'll probably use is I have some double-sided tape which is used for installing LCD screens into tablets and stuff like that. So I think that should just work fine. I'll just put a few little spots around here, and that'll just hold it in place. There we go. I think that's stuck on there pretty well. Right, so the next thing I need to do is have a look at trying to straighten these little bump stops up. There we go, it's looking pretty good. Just need to put the screws back in. Okay, the next step is to swap out the connector on the front here that goes to the Geiger Muller tube for a BNC one, which is a lot more practical than something that I don't have the other pair for. So I'm just going to unsolder this wire, remove the socket, and solder in new BNC and a new bit of wire, high voltage of course, and that should be a pretty simple job. Right, I've just noticed that the hole in the front panel here is a little bit too big for the BNC socket to sort of stay in snugly, so I've just borrowed one of the back retaining nuts off another one, and I'll put that on first, pop that in there, and that should just give me enough to actually attach this properly. Right, that's the BNC attached. Okay, all done. Just need to put it back in its box. I think at some point I will probably do something to hold this capacitor in place, because it's probably just going to break off again. I mean, look at it, twang. I've also noticed there's not really a ground connection on the BNC socket here. It looks like they're just using the chassis through this plate bar, and there's a ground point down in there which goes onto the PCB, but yeah, you'd think they would have something coming up locally onto the BNC, but no. Right, so it's all back in its box, all done. So now we can actually easily connect up some different probes. So this is a SBT11A, which is an old Russian tube, runs at 320 volts, so I've got this turned down to minimum. So, yeah, works perfectly. And we'll try plugging this into this tube, which is a Mullard MX145. I need a bit more voltage on this one, probably getting close to 500 I would have said. Yeah. Right, well, I'm really quite pleased with that, to be honest, how that's turned out. I think what I'll probably do now is give it a bit of a clean up and probably flip it out on eBay. I don't really have any use for a meter of this sort of size. I don't have a lot of room here in the lab either, so I think I'll just sell it on now I know it's working. So I hope you enjoyed this one, and we'll see you on the next video. Bye for now.